Last October, we featured a story about the increased use of unmanned aerial vehicles, or drones, that are being put to work in mining operations. We showed you various types of these UAVs, most of which are used at surface mines. Now, there are a few models that are designed to operate in certain underground environments, like this one, but it's challenging to fly drones underground, as you might imagine. You have to deal with confined space, reduced visibility, air velocity, dust concentration, and the lack of wireless communication systems. What about flying a UAV in an underground coal mine? Seems like that could be especially problematic, right? It presents a whole different set of challenges, starting with the lack of an available and permissible platform. In other words, drones can't really be safely flown in coal mines yet. My story this month is about two gentlemen in New Mexico who are working on a solution for solving that problem. They're going to tell us all about what they're doing right now. Meet Dr. Pedram Roghanchi. He's an assistant professor of mineral engineering at the New Mexico Institute of Mining and Technology, also called New Mexico Tech, in Socorro. And this is Dr. Mostafa Hassanalian. He's an assistant professor of mechanical engineering at New Mexico Tech. Together, they're working on an important project that could change everything we know about using drones or unmanned aerial vehicles in coal mines.
I should emphasize that right now we don't have a drone that can be used in underground coal mines.
When he says we, Dr. Roghanchi is referring to his team, but also to the mining industry at large. That's because of what's considered permissible versus non-permissible in coal mines by the Mine Safety and Health Administration, or MSHA.
We can use a commercial drone in underground metal mines, but we cannot use that in underground coal mines.
That's right. MSHA currently doesn't permit drones in coal mines, or at least their components. It's all about safety.
For underground coal mines, any equipment, any electrical equipment that goes underground should be permissible.
Permissible. In the case of drones, this means
the equipment that we send underground, it should be either intrinsically safe or explosion-proof.
Check this out. The Code of Federal Regulations. Title 30, Mineral Resources. Volume 1, Chapter 1. Subchapter B, Testing, Evaluation, and Approval of Mining Products. Part 6, Testing and Evaluation by Independent Laboratories and Non-MSHA Product Safety Standards. Part 18, Electric Motor-Driven Mine Equipment and Accessories. And Subpart D, Approval of Machines Assembled with Certified or Explosion-Proof Components. Currently, only MSHA's testing may be considered to determine if electric equipment is permissible. But this could change. The agency is reviewing comments to a proposed regulatory revision right now, which would streamline the testing and approval process for equipment permissibility in underground mines. MSHA might decide to adopt voluntary consensus standards from internationally recognized bodies for permissibility testing. Alternative tests could then be used to gain certification and approval, bringing the latest and best available technologies to create safer mine environments. This would be a very good thing because it would essentially mean making miners safer sooner. Drone technology is new and still changing rapidly, so it's not specifically mentioned in the regs yet. But if a drone motor or battery should generate a spark in an underground coal mine where there's any methane gas, for example, well, you can imagine the problem.
The equipment that we send underground, it should be either intrinsically safe or explosion-proof, because in underground coal mines, we have methane and oxygen, and combination of these two are very dangerous. And then if you have any sparks because of the electric equipment, then we're going to have explosion.
Roghanchi and Hassanalian are the perfect duo to solve this problem.
As I mentioned, my area of specialty is health and safety. So
I'm doing research on drones for about 15 years.
They're designing an intrinsically safe platform and propulsion system that will be flyable and safe, something that MSHA will hopefully approve and which will enable third-party manufacturers to build drones that can be safely flown in coal mines. In December 2020, Pedram and Mostafa landed a 3-year, $600,000 research grant from the Alpha Foundation and pulled together a team. In addition to several students and researchers, it includes Dr. Jane Lair from the University of New Mexico and Dr. David Wetz from the University of Texas at Arlington. Lair and Wetz are both professors of electrical engineering. The project has 3 phases.
In the phase 1, we plan to design a permissible battery for a drone and also a permissible motor for a drone. We also plan to make the electrical components and all the connections intrinsically safe. At the same time, our team, we are designing a drone, a configuration of a drone that can compensate the weight that added because of permissibility to that drone.
In a nutshell, here's the conundrum. Permissibility adds weight. More weight requires more propulsion to fly. More propulsion means shorter battery life. And the battery has to be safe.
For example, if you have a battery, you have to enclose that battery. The enclosure is the steel, and the steel has weight, right? So our idea is how we can make sure a drone is permissible, at the same time it's flyable.
So far, they've come up with more than 50 different configurations of what might or might not work for their design. They already know that a traditional configuration like this simple quadcopter drone won't work. They've considered adding more motors, having a coaxial configuration for each propulsion unit, or coming up with some micro-drone in the form of a monocopter that uses one motor with a larger propeller.
If we increase the number of the propeller with a smaller size, they are going to have lower efficiency than using a less number of propeller, but with a higher diameter or with different pitch angle. So
he gave you the answer.
It's obvious how passionate Mostafa and Pedram are about this project. Mostafa made sure that he showed us this.
This is something that we have multiple tracking cameras and tracking system, and this is a very safe place to test any drone that we have inside of this thing. And also since in the underground mines, we have ventilation, which is one of the challenges. So we are building arrays of fans so we can simulate this environment in the lab to perform this type of test.
In the second phase of the project, we are going to fabricate the drone. We are going to do a lot of destructive tests. And those destructive tests including, making the drone explode or the battery to burn.
This is how the team will get to see if the battery, the motors, the enclosure, etc. will be intrinsically safe enough to really meet MSHA standards or not.
And then in the third phase, we are going to make sure our configuration is optimized. What does that mean? That means that our drone is able to complete a mission, say for 10 to 20 minutes, can fly for a certain distances, say 200 to 300 yards. And so this is the hardest part, because we can design a drone that flies for 30 seconds and is permissible, but nobody is going to use it and nobody is going to pay for it.
And of course, they'll have to figure out how their drone will fly autonomously or semi-autonomously through a dark mine with various obstacles around, and not cause harm to anyone who may be working there.
This cage or this configuration that we are developing, we need to make sure that they can fly in the GPS-denied environment.
Ultimately, Pedram and Mostafa know that their platform will have to meet the strictest standards, and they remain enthusiastic about meeting the challenges.
We are working collaboratively with MSHA. They are very kind enough to give us their time and work with us on innovative approach to make the drone permissible. At the end of the day, though, we have to make sure We are going to meet all the standards and requirements that are mandated by MSHA.
We believe that we can achieve this project. We are so excited, and our students from these 3 universities are involved, and we believe that this is doable.
And we have the best team available. We are not alone. We are aware of at least two other companies, and we are working collaboratively with those companies as well, because our goal is not to make money. Our goal is to do research and advance the knowledge in the mining industry, and specifically to improve the health and safety of underground mines.
We'll keep you updated with the progress that's going on at New Mexico Tech in the coming months. Again, Pedram, Mostafa, and their team have 3 years on their research grant and some interesting challenges ahead of them. Now it's time to take a look at the new CORESafety video nugget. This one focuses on module number 14, and it's all about incident reporting and investigation. CORESafety's module number 14 deals with 3 important areas. First, understanding and reporting incidents. Second, investigating all incidents. And third, capturing lessons learned and data for management to review and communicate to employees. To prevent future incidents from occurring, there are 2 critical steps. First, integrity in reporting. Second, timely investigation. Start by determining if an incident is considered reportable or non-reportable to regulatory authorities. If it's a reportable incident, here's what to know. All safety and health incident investigations that are mandated to be reported should be promptly examined. You should be looking to identify the means to prevent the incident from reoccurring, and you should communicate it to the respective regulatory authorities as well as to company management. But even if it's a non-reportable safety and health incident, you should still investigate, analyze, and develop corrective actions. Then integrate them into your safety and health management system. Non-reportable incidents include near-miss events, property damage, and operational, maintenance, or process integrity incidents that could have a negative outcome. Now, let's talk about reporting. Incidents cannot be investigated if they are not reported. All personnel should be aware of what a reportable incident is within your company and as defined by regulatory requirements and company policy. All personnel should also understand the expectation to report an incident to management in a timely manner. To make sure a particular incident doesn't happen again, you really need to analyze and understand what caused it in the first place. But to do that, the incident itself has to first be thoroughly investigated from all angles. The better your investigation, the better the root cause analysis will be. Companies should make sure their personnel are adequately trained to conduct required investigations or maintain close coordination with external resources that are capable of doing so. Incident investigation should focus on fact-finding, not fault-finding. Finally, here's what every company should do. Make sure all personnel are trained. They need to understand the company's and the regulatory authorities' definition of a recordable, reportable incident and their obligation to comply. Investigate all incidents, including near misses, to the level of detail appropriate to their maximum likely outcome. All full investigations should reach root cause. Ensure that a sufficient percentage of company personnel representing all company functions are trained in effective incident investigation and root cause analysis. Capture the lessons learned and ensure that they are communicated to all personnel with a need to know. After an incident, compile the root cause data and forward it to management for their review of the safety and health management system. You can learn more about module number 14 by going to our website at CORESafety.org. And in July, we'll continue with CORESafety module number 15, Behavior Optimization. Until then, please be sure to follow our updates on Facebook and Twitter. For CORESafety and the National Mining Association, I'm Nelson Duffel. I'll see you here again next month. In the meantime, please be safe out there, and thanks for watching. Special thanks to Professors Pedram Roghanchi and Mostafa Hassanalian at New Mexico Tech for this month's interview on developing a safe propulsion system for UAVs in underground coal mines.
To share one of your safety stories, videos, or photos, email us at info@CORESafetyTV.org.